Lucky number 13. We're doing 13 on April 13th. Perfect. So I can't go through my day without coffee. True statement. It's a common statement from college students. So they did this experiment, it looks like, and the researchers said, hey, let's go out and give everybody, half the people, they said they're going to give the same test, and half the time they'll have coffee and half the time they won't have coffee, and we'll see how they do on the test. One of the researchers suggested that all the subjects have no coffee before Monday's test, and then 1 cup of coffee before Wednesday's test. Explain why this is a bad idea. Why is this a bad idea? It's not a bad idea if the researcher is actually working for a coffee company. It's like, hi, I'm a researcher. I work for Starbucks. Because what's going to happen potentially from Monday to Wednesday is that you're going to get better. So if you're going to get better from Monday to Wednesday, just because you're getting used to taking a test more, you're like, oh, I've just gotten better at this. What's going to happen? You're going to see an improvement. So you might confound the results, right? You might say, oh, look, you had this great improvement because you had the coffee. But the reality is maybe the improvement is actually from the fact that you got better. So what are we going to do? Well, let me write something that I just said down. Hold on, I'll hit pause so you have to listen to that all again. So I just reiterated what I wrote before, but now I figure I'm going to start saying something new. A better method would be to randomly assign half get coffee on Monday and half to get coffee. And then when the half get coffee, the other half don't. And then the other half And the good thing about that is that then you can just look at the difference in improvement. So you'll see an improvement perhaps in everybody from Monday to Wednesday. However, you'll be able to also then hopefully average out, because then you can see, well, some people might just be doing better on coffee in general as well. And maybe that's so you can kind of glean out by taking out the general improvement that happens from Monday to Wednesday. Okay, that was part A. Part B. Okay, they did it the right way. They used the better method, carried out appropriate tests to determine whether there's... Okay, so you see that column student? That column student is a huge giveaway. If you can have each variable in the column be assigned another label, like student 1 has no cup, 1 cup, student 7 has no cup, 1. So if every variable can be assigned another label, that's an appropriate label here, that's a meaningful label, like that's a student, that's some college student who's drinking coffee one day and not drinking coffee the other day. It's clearly paired data. So therefore we know that we're going to wind up doing a 1 sample t-test, and that 1 sample t-test is going to be on the differences. So we could also call that a paired t-test, okay? So we need to get the differences in the calculator, don't we? Yeah, all right. So we'll do that. Let's start with the stating first. Okay, so almost always the question is the difference 0? Now let's read the problem. What does the problem say? The problem says whether there's convincing evidence that drinking coffee improves memory. That's one-sided. So does improve this? So do we want it to be greater? We'll have it improve it. So we have to look at this real carefully. All right, sorry I had to go back and read that again because I'm going to change my variables up. Because I had to make sure that the kind of what we're measuring here is the difference is how many more. So we're going to say is how many more words do you recall with 1 cup versus no cup? So therefore, we want this to be greater than 0 if we want coffee to have an effect, right? So that's what we're trying to prove, that coffee improves your memory. And therefore, we're going to do a paired t-test. And I'm going to use an alpha of 0.5 because I'm not wise. Okay, now let's make sure our assumptions are true. Well, we have some problems, don't we? I mean, assuming that they did it the right way, they were randomly assigned the treatment, like we told them to do in part A, right? So we're assuming that they're randomly assigned the order of treatments. So, okay. And we could have done this multiple times, right? We could have gone out and did this another week, another week. So we're not really sampling without replacement. I'm not going out and saying, hey, you 10 kids only, we could have kept on doing this again. So I'm not really sampling without replacement. I mean, I guess if you said on that Monday and Wednesday, and you chose those 2 days specifically, then we are sampling without replacement, but we really could have done this multiple times. So whether you need the 10% rule here is debated, but when in doubt, write it down, right? Just in case somebody was saying, yes, if we only have a specific on Monday and Wednesday, the 10% rule is met because there are more than 100. There are more than 100 students that could have been surveyed. I mean, for the record, I don't think that's necessary. And then large counts. Oh, 10 is less than 30. Uh-oh, that's not good. So we need to look at the data now. So let's look at the data. Okay, I just did some quick subtraction. And all the data points are either 0, 1, or 2, which is, okay, surprising. Folks, it doesn't get much more symmetric than that. It's 3 zeros, 3 2s, and 4 1s. I mean, we could do a histogram real quick. Let's do a really quick histogram. Come back here and say, yeah, here's our little histogram. 3 zeros, 4 1s, 3 zeros, right? So even though the sample size is too small, right? There's no signs, no skew. I mean, there's absolutely no skew or outliers. So, I mean, based on these 10 data points, it definitely looks like it could be from a normal distribution. So 0, 1, or 2. So therefore, we're definitely going to say that we are approximately normal. We'll assume it's approximately. So we will assume that the distribution, the parent population, right? The parent population this came from is approximately normal. It might not be, right? There could be outliers out there, but wow, they're all positive too. Okay, so now we're going to do. Well, it's good to have some data. So let's think about what x bar is and what s of x is. Well, x bar is 1 without even blinking an eye. I mean, I don't have to do 1 bar stats to see that. But to do the s, I'm going to need that. So I'm going to come in here and just calculate that. And we find s of x to be 0.816. Okay, so we're just doing, all we're doing is just doing a t-test, right? And this is our x bar, our hypothesized mean is 0, and we're going to divide it by, 0.816 squared over 10. All right, so let's do that. 1 divided by the square root. I'm probably doing this faster than I am because I have to type into this. 8.1 squared over here and divided by 10. And we get 3.875. Wow, that's a big number. 3.875. That's a big number. So we're way out here. That's going to be small p-value, right? We don't have a whole lot of degrees of freedom, right? We have only 9 degrees of freedom. So when you have when you have a really low degrees of freedom, 3.875 isn't as considerable, but 9's not that small. So to find the p-value, we're going to do TCDF. We're going to go from 3.75 to infinity, or our proxy for infinity. And then we're going to use 9 degrees of freedom. Alrighty, so let's do our TCDF. Where's that number 6? 3.875 to infinity and beyond. Like seriously, what's beyond infinity? Come on, Buzz. 0.00, I told you it'd be small. 0.00188. 0.00188. And that's less than 1%, right? So therefore, we I guess I should change the color because I'm concluding. I mean, I like changing color just to show you the fact that we're moving to the other stages. You don't have to. You obviously wouldn't do this on a test, but it just makes sure you know that this now we're concluding, right? We will reject the null as our p-value is less than alpha. We have convincing evidence that drinking a cup of coffee helps you recall, I guess, more words. We don't want to make too much drastic conclusions other than that. I guess that helps me justify my cup of coffee. I have more than one cup of coffee a day habit. So yeah, I guess that helps justify it. Important note here is that I'm kind of concluding with some causation here. And the reason why I'm okay doing that is kind of implying the causation is because I feel like an experiment was done, right? If a good experiment was designed, like we talked about in part A, and they said, yeah, this method was good, you can conclude causation, right? You can. That's the whole point of an experiment, so you conclude causation. So I'm comfortable doing that. I'm comfortable saying that a cup of coffee helps you recall more words because if this was a true experiment, that's the whole reason you do it. I mean, you might need to be careful about who you conclude it for. Maybe you can't conclude it for, young kids or really old people. Maybe you can only conclude for the people that were like part of the study. So I think it was college students, if I remember correctly. But yeah, you gotta be careful with who you conclude for. But the whole point you do this is so you can conclude causation. So I'm not that uncomfortable with that conclusion that I wrote here. All right, folks, I'm done for now. Hope you enjoyed this. Talk to you soon.